Good morning or good afternoon, everyone, depending on where you are joining us from, and welcome to today's webinar. My name is Simon Thorpe from the Business Review, and I'll be the moderator for today's session. It's our great pleasure to have SEA with us today, who will be discussing how to maximize energy efficiency and exploration of energy audits and EPC in industry. Today's guest speakers are Antonio Ciccarelli, who is the CEO at SEA, and Gianluca Marcotullio, who is a design and process engineer. I'd like to take this opportunity to remind the audience that you could submit questions using the Q&A tool at the right-hand side of your screen, and you can do this at any point throughout the presentation. We're then going to allocate around 10 to 15 minutes to try and answer any questions or thoughts. So, without further ado, please allow me to welcome our first speaker. Over to you, Antonio. Please click the screen and carry on with your presentation.
Good evening. I'm Antonio Ciccarelli. I'm the CEO at SEA, Servizi Energia Ambiente. Today we'll talk about energy efficiency and our outline to begin talking about us, talking about my company, then to how to develop an energy audit, the contents of an energy audit, then the EPC contract that are the peculiar contracts for ESCOs, and then I will give the floor to my colleague Gianluca, and he will introduce you the case studies for cogeneration and industrial drying process and the security of power supplies. Then conclusion and question and answers. Let's start with us. SEA is a company founded in 2005 in L'Aquila, and we are an energy service company and even an engineering firm. Obviously, in engineering, because we need to have a great technical approach to our work. And the staff is made up by 12 experts. Most of them are engineers, because we always talk about kilowatt hour and something like that. And then we are active in the Italian white certificate mechanism since its beginning in 2006. And let me explain just a few of white certificate mechanism. In Italy, it's a kind of incentive, and it follows the principle that every ton of equivalent oil gives you a white certificate, so you can sell it on a stock market, on a peculiar stock market. It's a way the government finds to transform energy saving in money, and this mechanism is quite very good because it's made our sector be a very growing market. Then we are obviously accredited as an ESCO to the Italian Authority for Electricity and Gas, and in last year we were certified according to the Italian norm 11352. It is a provision for energy services in the public and private sector. We are about 70 companies have obtained this certificate in Italy. So we are very proud of this. Our fields of activity are obviously energy efficiency in the residential, tertiary, and industrial sector. In these sectors, we even perform energy audits. We make consultancy, and we operate in the Italian white certificate mechanism. And we are engineers, so we make engineers in fields of energy and research and development. For research and development, we now have a research project hosted by the National Institute of Nuclear Physics in Italy, and our research is about microelectrical generation of about 1.2 kilowatt from low temperature heat source. So it's a great thing we are now researching. Our motto in our company is that we produce energy savings. The energy audit scheme, we'll start talking about energy audit, is divided it into 4 parts. The first one is the pre-audit, is the preliminary meetings. So you have to know who you're talking to and which is the role of this person in the company to understand better how to speak with him Then you have to make the data collection and the process and operation knowledge and the site inspection. It's important because you have to know which kind of company you are facing to better understand which are the needs and which could be the efficiency you can do in that company. Then we pass to the current situation, and it's in which we evaluate energy consumption or divide it into services or activities and the energy fluxes. And this part is a kind of picture of the actual situation. So you understand how energy is used in that company. Then we pass to the field activities. You cannot make savings if you don't know the measures, if you don't know the quantities you are using. So it's deeper analysis of equipment efficiency and field measurement campaigns. The measurement campaigns is one of the most important things. You have to understand which is the consumption of electrical engines or heat production and heat wasting. Then, even with good and bad practices, it's important in an audit understand how workers, for example, act with energy, if they are good in using energy or not. At the end, you have the detailed analysis and the proposal. The detailed analysis, it's a collection of what you did until that moment, and then the final thing is the possibly efficiency measure. That's the most difficult part of the work, because you have to define the actions you can implement to reach energy efficiency. So that this is the scheme. Now let's see at the principle for an energy audit. There's completeness, so you have to be expert. You have to know what you go and ask for, and because often you will never find the same problem in two different companies. Then you have to the audit has to be reliability. So energy consumption by services has to be made in a good way. Then traceability is the deeper analysis. You have to take trace of everything you have done in the work. And then usefulness. But usefulness start to introduce the ESCO way of thinking, because the difference between an energy audit made by a consultant or an ESCO is this important difference. The consultant will be paid for the audit and will give you a perfect book in which you will have everything is possible to make energy efficiency in your company. ESCO has differently from the consultant as the same target of the customer. So for him, save energy is very important. So the study and the audit he does is real and is applicable in reality. Then consistency, obvious. You have to make a comparison to reality and use correct data. Norms we have in Italy and Europe for energy efficiency. The first one is an Italian norm, and it's about energy audit requirements. The second and the third are some kind of guidelines you can use for energy saving calculation and benchmarking. And the last one is the ISO 50001. It is an energy management system. Many of you maybe know this norm. Let's have a very fast look at the energy audit diagram. You have from one side the data collection, then energy performance indices calculation that's made by bills, for example. So you have these methods of gas or electricity. On the other side, we have to make a process analysis, then an energy inventory, so divide the consumption for equipment or sector, and then take operative energy performance indices. We have to compare these indices and to see if the data is consistent. If it's not, we have to come back to the process analysis until the data is it. If yes, the target energy performance, we will have target energy performance to compare with the consistent data. If everything is not always okay, and so we have to make this loop with the selection of energy efficiency action, with feasibility study and the priority of action until we reach our target. And at the end, there's the end of the energy audit. There's another thing I'd like to add, that energy audit is the most cost-effective investment in energy efficiency, because the cost of an audit is nothing compared to the savings you will obtain if you implement the action written on it. These are the contents of the energy audit final report and the context. So there are more or less general information you have to put on the analysis. Then the energy audit, that's what you need to make the picture of the actual situation of the company. And then the energy saving recommendations. You will have all these recommendations. It's the most difficult part of our job, and I would like just to point out that is appropriate economical analysis. ENESCO needs even to have economical approach to the thing, because every action is supported by investment and return of investment. At the end, we have we have ex post monitoring. If you want, you can put it on your energy audit, and it's something that gives the tool to the customer to demonstrate the saving, so the comparison between actual and expected saving, and gives the saving awareness to the customer. Then let's make an example on how a feasibility study has to be done, and what you have to put on in a feasibility study. You have to consider the investment, so the tailored breakdown of investment, including equipment, construction, and engineering. So everything you can consider, it's like every investment, you have to consider everything you need to make it. Then savings or earnings. There are about savings, we have to underline that savings are based on the variable energy cost, because if you when you make an action, the fixed energy bill costs remain the same, so you have to consider just the variable one. And then even the lower maintenance you will have with the new equipment. Then, as every business plan has to have, is that you have to consider direct costs, including operation and maintenance, insurance, and in this case, even extra fuel, for example, for a cogeneration, you have to buy to produce electricity. The payback period of almost every feasibility study is lower than 5 years, but the most typical one is around 3 years. We have never done an energetic audit with a payback period lower than 5 years. Then, as every typical business plan, we have to consider other items, as, for example, taxes, depreciation, loans, incentives, etc. And then at the end, consider economical index as net present value, internal rate of return, return on investment, or return on equity. So now we can make the poll question number 1, just to understand if you have ever performed an energy audit as a consultant, for who is a consultant, or as a customer if you are a company.
Okay, thanks, Antonio. Okay, right, to the audience, yeah, we're going to run the first poll of today's presentation. So in a second, you'll see a box on the right-hand side. If you select the answer that's relevant to yourself and then press submit. So we've just opened the poll, and you should see that on the right-hand side. And so the question is, have you ever performed an energy audit? so as consultant or customer. So the possible answers are A, yes, the audit never resulted in real actions. B, yes, the audit resulted in energy efficiency actions. C, no, I didn't know about energy audits as a tool for energy efficiency. Or finally, D, no, it is not our field of activity. Consultant energy is not a priority. So, Antonio or Gianluca,
yes.
Just while we're giving the audience a couple more seconds to input their answers, what's the sort of what are you hoping to see from this poll question?
Well, I think that the most clicked answer would be the first one. So the audit never resulted in re-election, because we very often find this situation in companies we go to visit and to make energy audits. So I expect the first one be the most clicked, the selected one.
Okay, so we're just closing off the poll now, and we'll put those results in. It seems, Antonio, I don't know until the actual answers solidified, but it seems like actually B came in as a top at 65%. So if you can actually see the poll on the right-hand side, I believe. Yeah, I don't know if obviously that's a little bit of a surprise to you, but yeah, if you want to just make a comment, and then please do continue with your presentation, Antonio.
Yes, it's good news for us, because solar energy saving is becoming every day a priority for everybody. So it makes me happy. It's very good news for us. We have many work to do. Okay, but now I can continue the presentation, and if you had, I can introduce you the EPC contract, so the energy performance contract, what it is. Sometimes it's you in your company you watch the possibility to make savings, and the saving has an interesting investment to do. So and it could be done by the customer, or due through an energy audit, or from a technology supplier. But normally, until now, the normal way to move is to ask for an engineering company to make design and saving evaluation, or to trust in the technology supplier to reach the energy savings. But there are some problems. You have to invest, the customer has to invest, you have to spend time, and then maybe you don't have the competence in this field to make this kind of investment. And the most important thing is, will I have the expected savings? Nobody in this way of working can answer to this question. So the solution could be EPC contract. It's a form of financing that allows funding energy upgrades from cost reduction under an EPC arrangement. ESCO implements a project to deliver energy efficiency and uses the stream of income from the cost saving to reply the cost of investment. So the ESCO helps you to make the investment, make the operation and maintenance, and then has been paid from the savings made. So the more the ESCO saves, the more the ESCO earns. That's a great principle that has the EPC. So how it works? In this diagram, we have energy and operation cost, and through the years, at the beginning, the situation we have now is the baseline of consumption, so the actual consumption. Then we decide to make some action, to implement some action. We make an audit, and then we decide to sign an EPC contract to develop energy efficiency measures. We will have reduced costs. So the energy savings is the difference between the baseline and the reduced cost. The reduced cost we will have through all the EPC contract duration, and then we will have the savings divided into customer savings that remains to the customer, and the contracting rate, that's the way the ESCO earns money making savings. So at the end of the EPC, when the ESCO ends the contract, the reduced cost remains the same, because the the plant or the operation and maintenance is done well, and all the savings pass to the customer. So the benefits, the main benefits, is the customer sources out the energy efficiency services, has guarantee of result, because if ESCO does not make savings, the blue rectangle will disappear, so the ESCO will not spend money. Then the customer will not have direct investment and direct labor, and savings for him will start from the first year. So will not, it doesn't make the investment, and he will save from the first year. He will use a specialized service, and at the end of EPC, all the refurbished or replaced equipment stay in the property of the company. So let's see the ESCO role in the energy performance contract. The ESCO is at the center and will solve so many problems. So you will have one partner for many problems or many things to do. So ESCO will make engineering, procurement and construction, operation and maintenance, finance, and even ask for incentives if they are present. We can divide the EPC in three kinds of models. The first one could be the total EPC, so the ESCO deals with all the aspects, including the investment, so the ESCO makes all the investment. The second one is similar to the first, but ESCO shares the investment with the customer. And the third one is a technical EPC. Sometimes it happens that the customer wants to make the investment because he believes in that energy efficiency measure. So you will have only the technical risk. You will pay it by the savings, but you will not make the investment. So we can now pass to the poll question number 2. And I give the floor to my colleague Gianluca, who will show you the case studies. So the poll question number 2 is if you are considering an investment in energy efficiency, which options is better for you? Thank you.
Thanks very much. Okay, so again, to the audience, similar as before, so the poll will come up on the right-hand side of the screen again. Please select the relevant answer to you and click submit. So, poll question number 2. If you are considering an investment in energy efficiency, which option is better for you? So we have A, external partnership for technical consultancy, only engineering. B, engineering and shared savings, so technical EPC. C, technical EPC plus investment, so total or partial EPC. And then D, no external partnership required. Okay, back to Antonio or Gianluca again. You know, similar question as before, sort of what you're hoping to see or what do you think you're going to see from this poll question?
Gianluca. Yeah, that's a good question. We actually don't know. It could be that most of the time at this stage, most of the companies will ask only for a technical consultancy. That's probably the most common way of doing this kind of investments. But let's see.
Perfect. Thank you, Gianluca. Okay, just a reminder to the audience, please do submit any questions you may have regards the presentation or any queries or thoughts. As I said, we will try and get through as many as we can at the end of this presentation. So back to Gianluca, we're just going to post the results now. It seems like it was quite close, but came out as on top. 38% of the audience clicked on C for technical EPC and investment, so total or partial EPC is the front runner. I mean, yeah, if you'd like to just make a comment, and then please, Gianluca, do continue with the presentation.
Yes, it sounds that the role of an ESCO is very well seen by the customers. They would like to have a partner that is not only giving a technical consultancy, but is at the same time investing out of their own pocket in the same activity together with the customer. So it seems that the ESCO business model is coming through, so it's good news again for us. Okay, so I'll move on with the presentation. So we start with the case study. As engineer in SEA, I was responsible for this project. This project deals with a customer which is a manufacturer in specialty fertilizers. So in the chemical broader sector. Just to give you a short overview of what the production site looks like, it is a medium enterprise, I would say, with a natural gas consumption natural gas consumption of 1.8 million cubic meter and 3.4 gigawatt hours, and about the peaks of power consumption is about 1,000 kilowatt. They already had a photovoltaic plant on the roof of their facilities. The output production of this company, of this production site, is in the order of several thousands of tons per year. What is used inside the production site is hot water, and in terms of energy carriers, of course, it's all hot water, medium pressure steam at about 12 bar, and hot air, and of course low voltage power from the power system. Okay. So we started off with looking at the process. The client here didn't want to have a full audit of the production side, but he wanted to focus on some part of the process, not all of the process. And there's a reason for that, because this part of the process is responsible for about 80% of the natural gas consumption inside. So that's why I wanted to look into this part of the process. We came up with a few solutions, mainly a CHP plant dedicated to a drying phase of the process, and then heat recovery again from the drying exhausts, and power recovery from steam expansion, because steam was produced at 12 bar but used at a much lower pressure. So from this expansion we would recover some power, and then a number of minor actions which would bring to about the 20% of primary energy saving in the overall site of production. But the core of the action is focused on the drying process. The drying process is responsible for about 80%, as I said, of the overall natural gas consumption. Here you have a very special product which comes in a watery solution, so in a slurry with 35% more or less of a dry matter, and this is fed to a dryer, and where it meets hot air at about 300 degrees, and then from the bottom of this dryer you recover the dry product. So this was the picture when talking about energy savings. Now there is another order of issues related to energy, which is power quality. In this particular process, was very sensitive to power quality. They have normally per year several shutdowns due to poor power quality, and this is due mainly to very short interruptions in the order of less than a second, from few milliseconds to about 3 seconds. And this is the cause for about 35 unintentional shutdowns per year, with a significant economical damage at the end of the day. So they were very sensitive to these issues. So they asked us also to look into this and to find a solution. The main problem is voltage dips. So interruption in the order of a few milliseconds when the voltage drops, and because of this, all the equipment for safety reasons shuts down and start the cooling down procedure. But let's move on with the energy saving measures. So let's focus on the drying process. We have 2 drying lines where air is heated up at 300 degrees and sent to a dryer. Inside the dryer it meets the wet product and is mixed, very well mixed. And at the bottom the dry product is recovered and there leaves the dryer at about 90 degrees. It is very important to keep that 90 degrees at the exit of the dryer to have a good measure of the drying effectiveness inside the dryer. So this is how the process looks like. Our CHP proposal, we went through, we analyzed a few technologies. The most common, of course, is internal combustion engine. This is most commonly used, at least in small and medium enterprises. But this is, of course, quite very common as a technical solution, but the thermal energy is made available at about 85 degrees, which is not suitable for direct use in drying. So we thought the best solution here was based on microgas turbine, which is a bit less common, quite uncommon, I would say, where you could use directly flue gases from the microturbine inside the dryer. So this is, of course, the option we chose. I must say that this plant had been visited already by many other dealers, with all of them proposed internal combustion engines, but the technical office of the production side never wanted to go on in that direction, whereas they opted for this one, this last solution I'm talking about. So let's see how it looks like. This is the actual, how it looks like, the actual dryer, drying process. So we just, aside to the present line, we just put a microturbine, and which produces power at the exhaust of the microturbine at about 200 degrees, 280 degrees. It's sent to a post burner just to rise the temperature a little bit more, and then to the dryer. So how the process looks like, very similar to the present process, where the post burner is used just to fine-tune the temperature in order to have to achieve the drying or the moisture, right moisture content in the dry product. So the control principles of this process stays about the same as it was before. We keep the old line, of course, in case the microturbine is not working. And this process is just one of the two lines. The microturbine gives slightly less power than the average power consumption of the site, so no power is exported to the grid, and this has economical reasons, of course. Okay, so this is how it works technically, and then I'll give some economic figures. Power savings in these sites are worth about 130 euros per megawatt hours, whereas exported power is paid at about 60 euros. So that's why we want to be a little bit less than, stay a little bit less than the average power consumption. No, we do not want to export power. Anyway, the net cash flow generated by the CHP is about 22% of the total energy bill, so it's substantial. If we look into the investment, the initial investment is paid by the savings in 4.2 year time, so in a relatively short period, even though gas turbines, as we know, are a more expensive piece of equipment than internal combustion engines. This is the reason why the present investment was budgeted by the client for this year, so it should be in construction in the course of 2014. Of course, this is not only about money, but saving energy has also some environmental concerns. Overall, the CHP allows for a CO2 net emission reductions in the order of 15 to 20%. So that's the reason also why this plant has access to the Italian well certificate scheme. So this is another way of income, another form of income from this kind of equipment. Okay, so moving on to the second focus, which is power quality. I'll give you just a screenshot of the power distribution inside the site. This is very simplified. And so we have delivery from the power from the electrical grid, and then we have the line is divided into two parts, let's say. One is feeding the very critical load, which is the process essentially, which should not be interrupted, whereas the second line goes to the offices or to less critical loads. We have an emergency generator already, but this generator, in case of grid failure or downtime, is not preventing the process from shutting down. And of course, is not helping in case of voltage dips. How it looks like now with the two microturbines which are connected inside the process, so are giving the power, as we said, an average power slightly less than what is coming nowadays from the grid. Now the power anyway can flow in both directions. Now the question comes, the question they asked us was, okay, now we have the microturbines, we should be also okay with the power quality issue. Now we should not be sensitive anymore to voltage dips. But unfortunately the answer is no, because the microturbines themselves, when they are working in a grid-connected mode, they're also very sensitive to voltage dips, to power quality. So what happens in case of short interruptions in the order of a few milliseconds, the microturbines themselves shut down and start the cooling procedures. So they cool down and you have to switch it on again. So the issue remains, and that might even get worse with the microturbines. So we need to find a solution for that. What we came up with is the use of a rotary UPS. UPS, I guess you all know, is uninterruptible power supply. It's a system that provides emergency power when the mains fails. We didn't use a stationary UPS based on batteries, but we prefer the flywheel for a few reasons. Because we have a better power quality, lower maintenance, high reliability, and lower operating costs, especially over the entire technical life, mainly because you don't have to change batteries once every 4 to 5 years. So this was our choice. What happens now that because of this UPS, we have more or less 100% availability ensured. So we don't have any more problems to the process due to voltage dips or poor power quality. Moving on, let's see now in this configuration what happens in a normal operation. So when we have an ordinary full load operation, the two microturbines just give power to the process. The flywheel just stays there, is available for use, but so it's continuously rotating as a stabilizing effect to some power cost, only minor power cost. But now what happens if we have problems? We have grid failures. So in the first case, in case of voltage dips, we see here an animation, the rotary UPS just make this voltage dip invisible to the process below, and all operations then may continue unaltered. For a longer period downtime, so for a grid downtime, the flywheel just takes over and gives enough time to the emergency generator to kick in and to provide power to the entire process. Then the process just continues standalone until the power is back. So for this reason we have 100% availability. Let's see now the economics. It looks like pretty much the figures I already showed before. So the energy saving is about the same as the UPS has only minor consumption compared to the whole process. although it has some costs, some investment costs. So the payback time is now from 4.2 to about 5.8 years payback. But here we are not taking into account any additional earnings due to the availability of the process, because it was just difficult to calculate. So anyway, it looks so nice that both of the investments have been budgeted for this year, so we should see construction during this year. So we cannot really talk about the economics of the flywheel itself, because it is difficult to estimate what is the gaining in terms of availability for us at least. But it should be very, very good for them. Here comes now for question number 3, which is about energy supply. So I can give the word to Simon, please.
Yeah, thank you, Gianluca. Okay, again, to everybody in the audience, final poll of today's session. So, again, same format. Please select the relevant answer to you on the right-hand side and submit your answer. So, poll question number 3 is, in the energy supply, what do you consider a priority? So we have A, energy efficiency, energy cost reduction, B, power quality, C, environmental concern, D, none of them. Okay, so the poll is open now, so if you make the relevant selection. Gianluca, yeah, back to yourself. What are you hoping to see from this particular question?
It depends, I think, very much on the nature of the manufacturer. Some of them are very sensitive to cost, some of them to power quality. But of course, there are also many which are not at all interested into energy costs, maybe few of them. Let's see what comes out.
Okay, so we're going to just close the poll now. So the results are just compiling, but it looks like we've got quite an overriding answer, which is A, Gianluca. So energy efficiency, energy cost reduction on that one. So yeah, is that what you were thinking?
Okay, very good then. Okay, so 95%, yes, very good. So everybody is interested in energy efficiency, so this webinar was relevant, I hope. Okay, moving on. We only have a few conclusions, and of course then questions and answers. Then one might ask why opting for an audit or energy efficiency measures in general. Well, it's very important to have awareness of energy use if you're a manufacturer. Results are guaranteed, especially when you do things properly, like going through a proper audit and then energy efficiency measure, maybe with the help of a specialized company like an ESCO. Lower costs, again, of course, means competitive advantage. Efficiency culture is good anyway, and we have environmental reasons. One, above all, CO2 emission reductions. And energy efficiency, again, is a growing market, so it's something that is coming up very nicely. What are the disadvantages? We don't know, actually, so if anybody, if you have some ideas, we will be happy to listen. That's all. Thank you all for listening. Simon, maybe you want to take over?
Yes, I will do. Thank you, Gianluca. Okay, so we're going to answer a couple of questions that have come in at this time to both Gianluca and Antonio. Please do keep submitting questions if you have any. If we don't get a chance to come to you or answer your question today, I'm sure the guys over at SEA will be in touch promptly after the presentation. Okay, so first question. In the project described in the case study, what was the role of SEA? So is it only technical consultancy, or was it sort of total or partial energy performance contract?
In this project, we started up as a technical consultant. Then we discussed all the options, actually, with the customer. In the end, they opted for making the investment themselves. At least this was the idea. So we took only technical consultancy, although we will take some technical risk. So we will be anyway, our reward will be based on the performance. So will just not be checked. So this was I hope I have answered your question, Simon.
I think so. I think so. Okay. So on to the next one. In terms of sort of time of projects, I think, how long does it take to perform a detailed energy audit?
That also depends. Depends on how deep you want to go with the audit. If you want to go through the details of your process, it might take even a couple of months for a very detailed audit. But sometimes it happens that a customer just wants to see some results very quickly. So we just start from few data to have a very first estimation of the numbers of what is potentially feasible. So that we shorten up to 2 or 3 weeks, but the optimum would be a couple of months, I would say.
Okay, thank you very much. Okay, so on to the next question now. It says here, what ruled out the use of the exhaust gas from the reciprocating engine for the spray dryer?
This is a reason of global efficiency. Now, if you have, you do have exhaust at the right temperature from an internal combustion engine, but that's not the only thermal energy you have available. Quite a big part of thermal energy made available by internal combustion engine is in the form of hot water at 85 degrees. So that would be wasted. That would remain unused. So this was the reason why we thought, and also put it down the numbers, the best solution was the use of gas turbine.
Great. Okay. So next question we have here is, do most companies already have the ability to obtain the data needed to determine areas for cost reductions, or are monitoring software packages usually not present?
Again, then depends on the detail you want to achieve. I think everybody has at least energy bills, and inside the energy bills you have already quite some data. Sometimes are quite detailed, at least in terms of peak consumption, average consumption, and all the rest. Then they have a number of data coming from the maintenance of the equipment, for instance, in terms of efficiency of the equipment and this kind of things. All these data, which are available nearly in all companies with the help of some expert, maybe visiting the site and talking to the technical personnel, then you may already get some relevant data, I guess. If you have monitoring packages, then it's of course a much better solution. Then you have maybe hourly detail of the consumption, energy consumption. That's of course much better. But it is not strictly necessary.
Okay.
I don't know if I've answered the question, but.
Oh, I hope you have, and I think you have. Okay. Yeah, there's another question here, which is, why is exhaust gas temperature from the microturbines so low?
So low? Yeah, it is low. Much lower than usual, because smaller size turbine normally are always equipped with so-called excuse me, I can't remember the name. recovery heat exchanger. So the hot gases, the hot flue gases, normally cooled down by heating up the compressed air after the compressor inside the recovery heat exchanger. So average temperature outside the heat exchanger is in the order of 2070, 2090 degrees.
Okay, brilliant. Right, I mean, I don't know if I want to come back to yourselves, Antonio or Gianluca, if you just want to sort of maybe summarize and conclude the presentation, you know, sort of final thoughts as you were, and then we'll wrap things up. But yeah, I'd like to just give you an opportunity to sort of summarize and address the audience for the final time.
Okay, thanks everybody for listening. I hope we just gave a very, very quick overview of the issue, which is indeed much more complicated and complex in itself. If anybody is interested in performing audits or something like that, we can just make contact with us. We are available to help. That's all, I think.
Lovely. Okay, and just to address the audience as well, the slides and the presentation will be available in the coming days. But again, you have Antonio's and Gianluca's contact information on screen now, so please do get in touch with them if you have any sort of pressing questions or you want to discuss anything immediately after the presentation. I guess that just leaves me to say thank you very, very much to Antonio and Gianluca for what was a great presentation. And thank you to SEA for sponsoring the session. As I mentioned, the presentation slides and the webinar recording are going to be available at www.business-review-webinars.com in the coming days. And we look forward to sharing further webinars with you. So please do keep an eye out on the website just mentioned. And you can follow us on Twitter, which is @BRWebinars for daily updates. And please join our LinkedIn group, Business Review Webinars. So thank you all once again for joining us, and we hope you have a great day.